Okay, a review of this detached building, what I've done with this so far to date. This was taken from the plot plan for your house, and I'm assuming that they have aligned that parallel with this portion of the road and not with the front. And so that's what I've done. I've aligned the front of this detached structure. Instead of the actual front, I've aligned it with the first notch back. Whatever you want to do there. I've also pushed it to the limit of the side yard setback, which is 10 feet. This leaves you about 47'9" between these structures if they put theirs at the 48.9 from this edge. And yeah, here you can see where I put my alignment back here, but whatever you want to do. Now this was wondering about that motorhome, a motorhome approaching 38 feet or so. And so here are where we talked about putting these garage doors. This is apparently the turning radius of about a 38-foot Class A motorhome. So I don't know whether you're going to be able to turn it in there or not. If you flip those garage doors around, I don't know. In any event, I downloaded this Walter White special just to horse around with this. And I think that is about 38, 39 feet long. And this is obviously imperfect, but I mean, it looks doable. I would hate to get that building built though and have it not doable. Okay, so just in case you want to reconsider whether you want to turn that building, if 47 feet is going to be enough, and I imagine a dealer themselves can probably tell you whether this is doable. I'm assuming this is going to be a poured concrete foundation. It's probably going to have to be 10 inches just to carry these 2x6 walls with the brick veneer. Here then is this, let me make sure. Here then is this 38-foot, 7-inch long Class A motor vehicle, motorhome. If you divide your space, pretty much directly in half, this is where how close a call that is with a 38-footer, 39-footer. It's just fitting. So if this is going to be adjusted any further back, either way really, let me know. So the front end of the garage out here, section A, is like this, and I was not sure, I didn't look in to see if they actually sold 16-foot pre-cut studs. I'm showing this wall as 16-foot studs, and then with the double top plate and the bottom plate you end up with 16'4" from the top of your foundation. And presumably that foundation is out of the grade 6 inches. It needs to be out 6 inches out of the grade anyway. So inside at the front end where the concrete is going to be the lowest, maybe 17 feet inside. And then I'm not sure, you probably run that concrete up on a slope for that first 40 feet perhaps, but I'm not sure about the rear. You begin to get into some clearance issues with a beam, possibly a beam back there. So not to go on, this continuing to look into the garage, this would be the line of the second floor drop down, which would give you about 9 feet nominally underneath that. Like that. Now, in terms of walling that off, or partitioning that off to the front and the back so that you're not having to heat the whole 4,800 feet, cutting that in half with sliding doors or some sort of partitions. I looked at some partitions. These were sliding doors on tracks. Is probably the most economical way. I don't know that for sure, but that's what I'm showing. And when you push these back, these are divided into 10-foot doors, and so when you push them back, you can have a max opening in here of 38 foot 2 when these are pushed to one side or the other. Here they are opened. I don't know if they sell something like that that would then fold back against the wall. I didn't want to spend a whole bunch of time researching. I looked at these things, and some of these look like they could do it. If this is really this just bottom one, which actually has Lexan or something like that in and can be made high enough as lightweight. These sort of situation when you, here it is here, it's just a track and etc. But push back against a wall, it's actually 2 inches per foot of opening, so even something like that pushed straight back against a wall is going to still project roughly 5 feet. They do have these curved tracks that it would go back into the against the wall like this, and then you would have about a 15 or 16 inch wide box by a 5 foot long box. That would get you the most wide open in there, where it's almost 56 feet wide open with these Lexan doors pushed back in here. I'm not sure whether you're interested in something like that. If this was another option. Turning to the actual structure though, to span the entire 60 feet, it's doable with two 24-inch high LVLs at 16 inches on center, or 3 of them at 24 inches on center. And when I say doable, I mean technically doable and technically passable. The total load is, the deflection is 2.5 inches at the center of the span, which to me, no wonder the pro rating is 0, which means the floor is very flexible and bouncy. So I didn't really think, and just economically, to run 3 pieces of these, I multiplied this out and came to something near $36,000 for the floor system. I don't know how that compares, but that's what I came to using wood, clear span 60 feet. And steel, these are the open web steel trusses, and those did not really, they didn't improve us. At least it's a perhaps an economically feasible cost to do them in steel bar joist type trusses, but even those are going to be 32 inches high to do it, at least according to my research. So if you wanted open span, that's what we're looking at generally. And on the second floor, I've sized everything for that second floor to be 40 pounds per square foot, which is typical living area space. I am concerned about someone getting trapped in here for fire under any circumstances. So perhaps some egress ought to be considered besides the stairwell. Perhaps that ought to be considered. So, but if you were to do this, the $36,000 floor system, if that's actually economical under the circumstances, because the alternatives are going to be steel beams, etc., this is what you end up with: a 2-foot diaphragm, wood diaphragm, 9 foot below, 8 foot up here. These trusses you can see are what they call top cord bearing, so those are going to be more pricey as well. These top cords, I don't know what they'll be. I'm thinking maybe they can do those with 2x8s. So the next logical step is splitting that span either in half or in thirds. Now, in talking about the members that will pass, this is, since these are manufactured members, they have this rating system, and to understand it, the numbers 0 to 70 or so, and the higher the number, the more stiff the floor is, and this is the customer satisfaction rate. I have always tried to get my numbers in the 40s, and I've not had any complaints. So keep that in mind in looking at some of these alternatives. Now this is when we split the span into two spans with a single steel beam in the center of them. We can do it with a 16 inch at 16 inches on center, but you can see the rating's only 24, and the deflection's an inch over each of those 30-foot spans, but it would meet code. It would just be a little more flexible. Of course, you can get a little bit better increasing the size of that member, still 16 inches, but it's a heavier duty, and then you increase the stiffness. You can see the deflection's gone down. So with a split span, with a single steel beam, it looks like 16 inches, even at 24 inches on center, would do it. Now these, however, are all of the possible solutions for this split span, and you can see that they range from 16 to 24 inches depending on how stiff of a floor you want it. Notice also, though, that all of their wood volumes are pretty similar, which means if you don't need the height, if you don't need the 8 inches in height, you could probably buy this more rigid floor for a similar cost as 16-inch high members. So that is with the split span. I sized some steel beams using this program written by a real mathematician, and these are the beam sizes I got for various arrangements: splitting it in half, splitting it into 3 bays, but with the center one still 30 feet long, and finally splitting it into 3 even bays. These are your dimensions of the beams here, and the weight per foot, etc. So using the 24-inch TJI 560s on a split span, this is, and with the beam that I sized, W21 by 111, this is what I came up with, 7'0" below the beam. And this is where that concrete, because remember, the concrete's going to slope up from the driveway. I would think that it's going to slope up at least somewhat to the center, at least, of the garage. If it's going to be level beyond that, then probably you will have this 7'0". But if it's going to go up much longer, this will become shorter. And I believe that needs to be held to 6'6", so know that. If you take that same thing, remember there were some 16-inch members that also passed code, and if you wanted that 8 inches down here underneath the beam, for example, you could go up like this, or if you wanted to lower that second floor, you would probably lower the ceiling as well, maybe reduce those truss prices. That's the split span B. This is the same span, 29-1, but it's split out into 2 beams. You can see the loading doesn't really change that much. The beam size does not either. And here the beam size becomes smaller, split into these 3 bays. So you have 3 bays divided evenly, or 3 bays divided with the wide one in the middle. This is with it divided in the middle, shown with a 2-foot diaphragm, 7'0" beneath the beams, ostensibly. Going to the 3 even spans, you end up with the most economical in terms of putting 2 steel beams in. This gives you the stiffest floor for the least size members. For my purposes, I just left it a 14-inch diaphragm, and this was what the section view looked like that. And I've just modeled things pending what you guys have to say about all of this. I quickly put the bathroom and the stairs up. They do clear that steel beam with room for the half bath. If this is to be a full bath, let me know if I haven't said that. Because I thought this was one of the more viable plans, it still just has these two columns here, but this is the one I developed just a little bit further, and I wanted this is a quick diagram to a quick series of diagrams. If these sliding doors, if this becomes the solution here with these 3 10-foot doors on each side pushed back against the wall. But with this, with the doors in this arrangement, you can slide those all to one side or to the middle, anywhere you want it, and have that kind of access to those 3 even-sized bays. This was the long section cut through here, and this is our 80-inch clearance from the stairs. With some creativity, you could get away without having to have a column to pick up that last joist here. This is shown as a 2x10, which actually would pass. You would still have to pad this down here and there, but you can see that it lends itself to it. The long view beyond the stairs, and showing the necessary steel beam, the 14-inch diaphragm, the space upstairs. This remains to be completely designed, but this is the beginning of it. And really, these are the steel doors then in a solution for hanging those. These are just standard farm door tracks, 2-inch farm doors on rollers, and this some sort of angle that needs designed to just carry the weight of those doors. I have the last member here as an LVL to give a solid bolting frame for this piece. But that's what I've come up with so far, and hopefully some of this will clarify some of your possible alternatives. Let me know, and thanks.